Usually, when we create a design in architecture, not talking about electrical engineer, but in architecture, if we use a tool called Rooms located under the tab Architecture, it identifies what will be the use of each zone of our building. It may be a cafeteria, a conference room, etc. However, when we make use of Revit tools for analysis, specifically talking about electrical engineering, the tool Rooms is not enough to identify these environments. We must use something else, a tool much like Rooms. If we go to the Analyze tab, it is called Spaces. If we see here the help that emerges from the tool, we will see how the spaces are placed and how they behave. Looks a lot like the rooms, but unlike the rooms, they give specific information to each discipline. Click on that button and we can see that in the Instance Properties palettes, note that there is a group called Electrical Lighting, and here it is giving us data, not given by rooms. It is showing other data, as for example, what is the average estimated illumination depending on the amount of luminaires that can be placed within that space. What is the reflectance of the ceilings, walls, and floors? At the end, we also find analytical data. Of course, some of this data is taken to design of mechanical installations such as air conditioners. For example, if we click where it says Space Type and we click on the End button for editing, there are also some calculations that have to do with electricity such as lighting, low density, watts per square meters. That will be an average depending on the kind of space that is defined. Also, there is power load density in watts per square meters and the lighting and power schedule. All these factors that we need in the electrical design and that they are defined inside the space. That's the main difference between a room and a space. An architect can use a room to say what is the use of an area, but in the case of any mechanical or electrical designs, both disciplines need them. Spaces give us data that facilitates the calculation of installations, not only for architecture. How do we define them? We said that it's much like using a room, so it should automatically identify which ones are the edges of space using the walls, but that is not happening in this case. It is not detecting the outer walls, and that's because we are using an architectural link. Before you start placing the space, we press Modify, select the link, and edit type properties, and we must always verify where it says Constraints that the room up bounding option is enabled. When this is enabled, it begins to recognize the rooms previously created in architecture and use those edges to create spaces in our energy analysis. If I return to Analyze and I click on Space, note that it takes it into account. We will place the space here and see what else we have to take into account, specifically when we analyze lighting. If we select a space, it's calculating the parameters we talked about previously. At this point, it's 0 because there are no luminaires. Now I'm going to a reflected ceiling view for this floor on the entry level, and I will use this view to place luminaires. Later, we will see how to make this placement in more detail. For now, I just want to show you how space works when lights are positioning, so we'll do it briefly. We go to System, Electrical, Lighting Fixtures, and we place on face any luminaire. I'll put several of them around here to this side, and if I go to the edge, I can select the space. Realize that now it is calculating the average estimated illumination. It is calculating what lumens are here on average on this luminaire. That is a product of the internal properties of this luminaire. If we selected Edit Type, you will see that there is something called Photometrics down here, and see that there are the illumination properties, lumens per watts. With these settings, it automatically used in the space, it is estimating what the average lighting is for that environment. But now I'll show you something else. If we create a section view, we will make a sectional view upwards. Now right-click on the view, go to View. Note that it is calculating the space. Here are the two luminaires that are up, and it is calculating these luminaires, taking them in count, because they are within the volume of space. But if we change the elevation, we lower it, it reaches a height that no longer calculates illumination because they are not inside. Why I'm referring to this? It may be because we are a discipline that inherits the basic architecture model. It might be that the responsible for creating these spaces may have been a mechanical engineer. He is not interested in calculating the volume of air conditioning over the ceiling. He only wants to feed or condition the atmosphere below the ceiling. That can lead to the misconception that these lights do not fall within the volume and we cannot compute the amount of lumens needed. We should verify that the height is correct. And Revit is smart enough to know that if it's right up to the ceiling, it calculates them, even if not fully embedded. If you are near, it takes them into account. However, we must ensure that the height is correct. If the luminaires are within the space, they will be taken into account for the calculation of the amount of illumination. That is a factor to consider. Another factor to consider is that whenever we are working with spaces, we need to verify that the volumes are calculated. If we return to architecture, under Rooms and Area and Volume Computations, observe that it is enabled. Volumes are computed at finished phases. But we can choose the option that it only compute the areas and not volumes. What will happen in this case? Our file will be faster, especially when we have many spaces. Now that we select the space using the upper edge. Note that it is not taking into account what happens to the ceiling. Why? Because computing volumes is not enabled. It still is estimating the average illumination. Note that the average illumination is at a specific height. This must also be taken into account. It is not an exact illumination calculation because it is taking an average level of illumination of all the lights. If there are lights above, below, or it will not be exact. It is taking the total volume to be calculated. It is not taking the exact volume. If we want to carry out a lighting calculation with a real volume, we must ensure in architecture, on the Rooms and Area, that the option is enabled for both areas and volumes. Perhaps to do this one by one will be tedious. We'll see how we can use tools to do that. Here in the section view, I will remove these slides that we will no longer need. I only place them for a test. Let's see how we can place automatically at the same level all the necessary spaces. I will erase the space and note that when I try to erase it graphically, it gives up a warning where it says, a space was deleted from all model views but still remains in this project. To delete it, we'll have to use the schedule or something similar or use the system browser. How is that? To be able to work with spaces, we must go to the View tab and in User Interface, activate something called System Browser. As there is a project browser, we should also enable the System Browser. The system browser shows different systems: mechanical, plumbing, and electrical. So far, we have not created any, so it's 0. But if we change here from system to zones, note that there is a default zone, and within that zone, there is a space. If we go to properties, we see the properties of the space. To erase it, either we press delete or right-click and delete. That's the way to work the spaces. They cannot be erased graphically only. It won't have the desired effect. We have to do it from the system browser, or maybe if we have to create a schedule, delete it directly from the schedule. How do we automatically create in the level the necessary spaces? Back to the Analyze tab. We create a space, and here we find a tool called Place Spaces Automatically. It will automatically place the space. Note that the upper limit should be 0 to floor, and we type an offset of 0, so that it will automatically place all the spaces with the upper floor from the 2. There will be new spaces. And we press Place Spaces Automatically. There are 35 automatically created spaces at this level. If we go to the section, note that here in this space that we have created and it was successfully created. We can do this for each of the levels. Now back at the entry level where we can see that all spaces are called space. This does not help much, and also they have random numbers. If you are working on a coordinated project, which means we're getting the information from the architect, a good practice will be that spaces are called like the rooms created by the architect. This will facilitate the coordination task. How do we make them have the same name? Because otherwise we will have to change them out manually, and that can be very tedious. We will change their names here using the space instance properties, but that will take a long time. Instead of changing the name here, what we do is go to the Analyze tab and observe that there is an option called Space Naming. It offers us the possibility of receiving the names and numbers from the rooms previously created by the architect and copy them into our spaces. If there are no rooms in that space because the architect didn't create it, there's no problem. It will leave its default name. It can be applied for all levels. Note that because we have only created spaces at level 1, the only option that appears. We press OK. What has it done? Note that it has changed the name and number of each to what is really happening in architecture. Note that there is a 1 in front of every space because it is floor 1 and it will account like that. This will facilitate our control task. If we return to the system browsers, we see all the spaces that we have created, and we can select their properties. For a review, whenever we work with spaces, we must ensure that in rooms and area and volume computation, that volume calculations are enabled when we create a lighting analysis. We must always check that the heights are correct. In this case, it has created them to the 2nd floor, and that it contains the luminaries to take into account the calculation of lumens, and the 3rd step always to check that when we use link, that within its type properties the room bounding is enabled.